Time. It marches forward, unwavering and absolute, or so we thought. For centuries, humans perceived time as a rigid framework, ticking away at the same rate for everyone, everywhere. But what if I told you that time is not the steadfast constant we believed it to be? What if time, like a river, could speed up, slow down, or even bend? This is the mind-bending reality revealed by Albert Einstein's theory of relativity. Prepare to have your perception of time forever altered. Albert Einstein, a name synonymous with genius, revolutionized our understanding of the cosmos. His theory of relativity, presented in the early 20th century, shattered the illusion of time as an absolute entity. Einstein boldly declared that time is not absolute, but relative. Time, according to Einstein, is intertwined with space, forming a unified fabric called space-time. This fabric is not rigid but flexible, capable of being warped and stretched by gravity and motion. One of the most intriguing consequences of Einstein's theory is time dilation. Simply put, time dilation means that time passes at different rates for observers who are moving relative to each other. The faster you move, the slower time passes for you relative to someone who is stationary. Imagine two identical clocks, one remaining on Earth and the other traveling at incredibly high speeds. When the traveling clock returns, it will show a slightly earlier time than the clock that remained on Earth. This is not a mechanical error, but a fundamental principle of the universe. The faster clock experienced time dilation, causing time to slow down relative to the stationary clock. Let's dive deeper into time dilation with a thought experiment. Imagine a train traveling at near the speed of light. Inside the train, a passenger shines a light upwards to the ceiling. From the passenger's perspective, the light travels in a straight line, bouncing directly back down. However, to an observer standing on the platform outside the train, the light beam appears to travel diagonally. This is because the train is moving horizontally while the light is traveling vertically. Since the speed of light is constant and the observer sees the light travel a longer distance, time itself must slow down on the train for the observer on the platform. Time dilation is not just a theoretical concept, it has real-world implications. One of the most striking examples is the Global Positioning System, or GPS. GPS satellites orbiting Earth rely on incredibly precise atomic clocks to provide accurate location data.
However, these satellites are also moving at high speeds, experiencing a slight time dilation effect.
To compensate for this, GPS satellites have their clocks adjusted slightly, taking into account the time dilation predicted by Einstein's theory.
Without this crucial adjustment, GPS navigation systems would be significantly inaccurate, highlighting the tangible impact of time dilation on our everyday lives.
Section 6. Time dilation and astronauts. A journey into the future. In this chapter, we delve into the fascinating concept of time dilation and its profound implications for astronauts venturing into the vast expanse of space. The effects of time dilation become even more pronounced in the realm of space travel. As spacecraft travel at incredible speeds, approaching the speed of light, time itself begins to behave differently.
Astronauts aboard the International Space Station, orbiting Earth at high speeds, experience a minuscule but measurable amount of time dilation. This phenomenon, though subtle, is a testament to the intricate relationship between velocity and time. Orbiting Earth at high speeds, these astronauts are part of a living experiment in the effects of time dilation. The faster they travel, the slower time moves for them compared to those on Earth. Experience a minuscule but measurable amount of time dilation. Upon returning to Earth, astronauts are technically a fraction of a second younger than they would have been had they remained on the planet. This tiny difference, though imperceptible in daily life, is a glimpse into the potential future of space travel. Astronauts are technically a fraction of a second younger than they would have been had they remained on the planet. This phenomenon, while small, opens the door to intriguing possibilities for long-duration space missions.
While the time difference experienced by astronauts on the ISS is small, future missions to distant stars and galaxies could result in significant time discrepancies. Imagine a journey to a distant star system where the effects of time dilation become much more pronounced. Future missions to distant stars and galaxies could result in significant time discrepancies. For astronauts traveling at near light speeds, time would slow down dramatically relative to those on Earth. This means that while only a few years might pass for the astronauts, decades or even centuries could elapse on Earth. For astronauts traveling at near light speeds, time would slow down dramatically relative to those on Earth. This phenomenon, known as time dilation, could have profound implications for the future of space exploration and our understanding of the universe. Time would slow down dramatically relative to those on Earth. This means that while only a few years might pass for the astronauts, decades or even centuries could elapse on Earth. The implications of this are staggering, as it challenges our very perception of time and reality. They could return to Earth after years of interstellar travel to find that decades or even centuries had passed. This concept, while theoretical, is grounded in the principles of Einstein's theory of relativity and has been observed in various experiments, to find that decades or even centuries had passed. The future of space travel holds many unknowns, but one thing is certain: the journey into the cosmos will forever alter our understanding of time, space, and our place in the universe. Section 7. Extreme time dilation, black holes. The ultimate cosmic time warpers are black holes. These enigmatic objects are formed when massive stars collapse under their own gravity, creating a point in space with an incredibly strong gravitational pull. These gravitational behemoths possess such immense gravity that they warp the fabric of space-time to an extreme degree. The closer you get to a black hole, the more intense this warping becomes, leading to some truly mind-bending phenomena.
Time near the event horizon, the point of no return for a black hole, slows down to a crawl relative to observers at a safe distance. This boundary marks the limit beyond which nothing, not even light, can escape the black hole's grasp. If you were to observe a spacecraft falling into a black hole, you would witness a bizarre spectacle. The spacecraft would seem to slow down as it approached the event horizon, appearing almost frozen in time. As the spacecraft approached the event horizon, it would appear to slow down, its movements becoming increasingly sluggish. This is due to the extreme time dilation caused by the black hole's immense gravitational field, its image red-shifting as time itself stretched to infinity. The light from the spacecraft would be stretched to longer wavelengths, making it appear redder and dimmer to an outside observer.
From the spacecraft's perspective, however, time would seem to flow normally, as if nothing unusual were happening. The crew inside would experience time at its usual pace, unaware of the dramatic time dilation occurring outside, a testament to the relative nature of time. This phenomenon highlights the fascinating and often counterintuitive effects of extreme gravity on the passage of time, reminding us of the complex and mysterious nature of our universe. Section 8. Time travel. A distant possibility. The concept of time dilation inevitably leads us to ponder the tantalizing possibility of time travel. Could we one day harness the power of time dilation to journey into the future or even the past?
While time travel remains firmly in the realm of science fiction, Einstein's theory does not explicitly rule it out. Some physicists speculate that wormholes, theoretical tunnels through space-time, could potentially act as shortcuts for time travel.
However, the existence of wormholes remains purely theoretical, and even if they do exist, navigating their unpredictable nature would be an immense challenge.
Section 9. Conclusion. Time is a river, not a straight line. Einstein's theory of relativity shattered our Newtonian view of time as an unwavering constant. Before Einstein, time was seen as a universal clock, ticking away uniformly for everyone, everywhere. This classical view was comforting in its simplicity, but it was also misleading. Einstein introduced the radical idea that time is not absolute. Instead, it is intertwined with the fabric of space itself, forming what we now call space-time. We now know that time is a fluid and relative concept, influenced by gravity and motion. Imagine time as a river, its flow changing speed and direction depending on the landscape it traverses. In the presence of massive objects like planets and stars, the river of time bends and slows. This phenomenon, known as time dilation, means that time can pass at different rates depending on where you are and how fast you're moving. Time dilation, a consequence of this revolutionary theory, has profound implications for our understanding of the cosmos and our place within it. For instance, Astronauts aboard the International Space Station experience time slightly slower than we do on Earth. This effect, though minuscule, is measurable and has been confirmed through numerous experiments. It challenges our intuitive understanding of time and forces us to rethink our place in the universe. From GPS satellites to the journeys of astronauts, time dilation is not just a theoretical curiosity, it is a fundamental aspect of our universe. GPS systems, which we rely on daily for navigation, must account for time dilation to provide accurate positioning. Without these corrections, the system would quickly become unreliable. This real-world application underscores the importance of understanding time as a dynamic and relative entity. As we continue to explore the cosmos and unravel its mysteries, our understanding of time will undoubtedly continue to evolve, leading to even more mind-bending discoveries. Each new mission, each new observation, adds another piece to the puzzle. The more we learn, the more we realize how much we have yet to understand. The journey of discovery is ongoing, and the river of time flows ever onward, carrying us toward new horizons. Ultimately, time is not a straight line but a winding river, its flow forever intertwined with the fabric of space-time. Just as a river can carve through mountains and shape the land, the flow of time shapes our universe and our understanding of it. Embracing this fluid and dynamic nature of time opens up endless possibilities for exploration and discovery, reminding us that the journey is just as important as the destination. The concept of time travel has captivated the human imagination for centuries. From ancient myths to modern science fiction, the idea of moving through time has always fascinated us. We see it in literature, film, and our wildest dreams. The notion of stepping into a time machine and visiting different eras is a recurring theme that never loses its charm. The ability to journey through time, to witness historical events, or to get a glimpse of the future holds an irresistible allure. Imagine standing on the deck of the Titanic or witnessing the first moon landing. This desire to explore the unknown, to change the past, or to peek into the future is a testament to our innate curiosity about the nature of time itself. It's a reflection of our deepest desires to understand our origins and destiny. But is time travel merely a product of our imagination, or could it one day be within the realm of possibility? Could we ever build a machine that transcends the boundaries of time? Science fiction has explored the possibilities and consequences of time travel extensively. These stories stretch our minds and challenge our understanding of reality. From H.G. Wells' The Time Machine to the intricacies of the Back to the Future trilogy, we have been both entertained and challenged by the implications of manipulating time. These narratives invite us to ponder the ethical and moral dilemmas of altering history. These stories often serve as cautionary tales, highlighting the potential paradoxes and unintended consequences that could arise from tampering with the fabric of time. They remind us that with great power comes great responsibility. While time travel remains a theoretical concept, the pursuit of understanding its possibilities pushes the boundaries of our scientific knowledge. Researchers continue to explore the mysteries of time and space, driven by the hope of one day unlocking its secrets. It compels us to ask fundamental questions about the nature of the universe, the nature of causality, and our place within the grand tapestry of time. The allure of time travel is not just about the destination, but the journey of discovery itself. Albert Einstein, the renowned physicist, revolutionized our understanding of space and time with his groundbreaking theory of relativity. His insights have fundamentally changed the way we perceive the universe and our place within it. His work laid the foundation for the theoretical possibility of time travel, suggesting that time is not absolute but is relative to the observer's frame of reference. This was a radical departure from the Newtonian view of time as a constant, unchanging entity. Einstein's equations showed that time can be stretched and compressed, a phenomenon known as time dilation. This means that time can flow at different rates depending on the speed at which an object is moving. One of the most intriguing aspects of relativity is the concept of time dilation, which states that time passes slower for objects moving at high speeds relative to a stationary observer. This has profound implications for our understanding of time and space. This effect becomes more pronounced as an object approaches the speed of light. The closer an object gets to this ultimate speed limit, the more time slows down for it. For example, if one were to travel in a spaceship at a significant fraction of the speed of light, time would pass slower for them relative to someone on Earth. This is not just a theoretical concept, but a real effect predicted by Einstein's equations. This means that upon returning from their journey, the traveler would have aged less than their Earth-bound counterparts, essentially traveling into the future. This fascinating idea has captured the imagination of scientists and science fiction writers alike. While achieving such speeds is currently beyond our technological capabilities, the concept of time dilation has been experimentally verified using atomic clocks. These experiments have shown that time does indeed pass at different rates depending on the relative speeds of the clocks. Another intriguing concept that emerges from Einstein's equations is the possibility of wormholes, theoretical tunnels that connect two distant points in space-time. Imagine folding a piece of paper in half and poking a hole through it. That's a simplified visualization of a wormhole. These cosmic shortcuts could potentially allow for travel across vast distances, even between different points in time. However, the existence of wormholes remains purely theoretical. One of the major challenges lies in the fact that they are incredibly unstable and would require exotic matter with negative mass energy density to hold them open. This type of matter, while theoretically possible, has never been observed. Despite these challenges, the concept of wormholes continues to fascinate physicists and science fiction enthusiasts alike. If we could somehow harness the power of wormholes, we might be able to unlock the secrets of time travel and explore the universe in ways we never thought possible. Beyond wormholes, another theoretical construct proposed by physicists is the cosmic string. These are hypothetical, one-dimensional defects in space-time, remnants of the early universe's formation. Imagine them as incredibly thin, extremely dense threads of energy stretching across the cosmos. While their existence is yet to be confirmed, some theories suggest that cosmic strings could potentially be manipulated to create closed, time-like curves, essentially loops in space-time that could facilitate time travel. The immense gravitational pull of these cosmic strings could, in theory, be harnessed to warp space-time sufficiently to create closed, time-like curves. A spacecraft, for instance, could theoretically travel along such a curve, effectively traveling back in time. However, the challenges associated with manipulating cosmic strings are even more daunting than those posed by wormholes. Not only do we need to confirm their existence, but we also need to develop a deep understanding of their properties and the technology to harness their immense energy. While the concepts of wormholes, cosmic strings, and time dilation offer tantalizing possibilities for time travel is riddled with paradoxes that challenge our understanding of causality and the very fabric of reality itself. The most famous of these is the grandfather paradox, a thought experiment that has puzzled scientists and philosophers alike. It poses a rather disturbing question. What would happen if you traveled back in time and accidentally killed your grandfather before your parent was born? Would you cease to exist, vanishing from the timeline as if you were never born? Or would the universe unravel, unable to reconcile the paradox, leading to a cosmic disturbance? This thought experiment highlights the potential contradictions inherent in time travel, making it a fascinating yet perplexing topic. Several solutions have been proposed to address the grandfather paradox, each with its own intriguing implications. One possibility is the existence of parallel universes or alternate timelines, where each action creates a new branch of reality. Perhaps traveling back in time transports you to a parallel universe where you can interact with the past without altering your original timeline, thus avoiding any paradox. Another solution is the Novikov self-consistency principle, a theory that offers a different approach to resolving these paradoxes. This principle posits that if you were to travel back in time, something would always prevent you from changing the past in a way that would create a paradox, ensuring that events remain consistent. Essentially, the universe has a way of self-correcting to maintain consistency, preserving the balance and order of the cosmos. Even if we could overcome the paradoxes associated with time travel, the practical challenges are immense. Creating wormholes or manipulating cosmic strings would require unimaginable amounts of energy, far beyond our current capabilities. We would need to develop technologies that can harness and control these energies, a feat that currently lies firmly in the realm of science fiction. Furthermore, the stability of wormholes or time-like curves created by cosmic strings is questionable. Maintaining a stable passage through time would likely require a mastery of exotic matter and its properties. We are still a long way from fully understanding these theoretical concepts, let alone manipulating them to our advantage. While time travel remains a distant dream, the pursuit of understanding its possibilities continues to drive scientific inquiry and technological advancement. While we may not be hopping into time machines just yet, we do have concrete evidence of time dilation, one of the intriguing consequences of Einstein's relativity. Experiments with atomic clocks have demonstrated that time does indeed pass slower at higher speeds. For example, atomic clocks flown on jets have shown a minuscule but measurable time difference compared to their Earth-bound counterparts. While this time difference is incredibly small, it provides tangible proof that time is not absolute, but is influenced by speed. This subtle manipulation of time, while not quite time travel in the traditional sense, offers a glimpse into the mind-bending possibilities that govern our universe. Time, as a concept, continues to fascinate and baffle physicists and philosophers alike. Is it a fundamental aspect of the universe, or is it an emergent property arising from something more fundamental? Does time flow in one direction, or is our perception of its passage merely an illusion? These questions lie at the heart of our quest to understand the nature of reality. The pursuit of time travel, whether it remains a distant dream or becomes a future reality, compels us to confront these fundamental questions and to expand the boundaries of our knowledge. While the practicalities of time travel remain firmly in the realm of science fiction, the pursuit of understanding its possibilities continues to inspire scientific exploration and technological innovation. The quest to unravel the mysteries of time pushes us to ask fundamental questions about the universe and our place within it. Who knows what breakthroughs await us in the future? Perhaps one day, armed with a deeper understanding of the cosmos, we will unlock the secrets of time travel and embark on journeys through the annals of history or into the uncharted territories of the future. Until then, the dream of time travel will continue to fuel our imaginations and inspire us to push the boundaries of human ingenuity.
Have you ever wondered how far humanity could go in its pursuit of knowledge? Could we, as a civilization, ever overcome the ultimate boundaries of existence? What happens when even the most advanced technology fails to answer the fundamental questions of reality? These are the mysteries that have haunted thinkers for centuries and continue to challenge us today. Imagine a civilization so advanced that it spans galaxies, with technologies capable of capturing every wavelength of light from the farthest corners of the observable universe. A civilization that has unlocked the secrets of the quantum realm, colonized countless star systems, and reshaped entire galaxies to suit its needs. And yet, despite their unimaginable power, they find themselves unable to answer one of the most profound questions. Are they truly alone in the cosmos? This is the story of the great arcships, colossal vessels that carry the dreams and ambitions of a civilization reaching for the stars. But as their journey unfolds, they realize that the universe they inhabit is just one of infinitely many. What does it mean to confront infinity? Can any civilization, no matter how advanced, grasp the scale of an infinite multiverse? And if they can't, what is the ultimate limit of knowledge? These questions set the stage for an extraordinary tale of exploration, despair, and discovery. A story of how a civilization, in its relentless pursuit of answers, discovers not only the vastness of the cosmos, but also the boundaries of their own understanding. So how far could we go? How much could we ever truly know? The infinite multiverse. It began as a whisper among their greatest minds, an idea so radical that many dismissed it outright. For eons, the civilization had looked upon their universe as the ultimate arena of existence. Vast, incomprehensibly large, yet singular. They had built galaxy-spanning observatories, devices so sensitive they could detect even the faintest remnants of light from the birth of their cosmos. They had peered into the quantum realm, uncovering particles and forces that danced on the edge of reality. Their arcships had traveled across intergalactic voids, bridging the unimaginable distances between galaxies. Yet, despite these monumental achievements, something remained elusive. The realization came not from one breakthrough, but from a convergence of discoveries across disciplines. Slowly, piece by piece, the evidence pointed to a staggering conclusion. Their universe was not alone. It was but one in a vast multiverse, an infinite collection of universes, each with its own set of physical laws, its own histories, and its own possibilities. At first, the idea was exhilarating. The multiverse promised a playground of infinite variety. If one universe could give rise to life and intelligence, how many more might teem with civilizations beyond their imagination? If their own cosmos held wonders and mysteries, what untold marvels might lie in the realms beyond? It seemed as though the multiverse was the ultimate frontier, a boundless expanse of exploration and discovery. But as they delved deeper into the implications, the exhilaration gave way to unease, and unease to despair. The multiverse was not just infinite in its scope, it was infinite in every possible way. For every universe that mirrored their own, there were countless more, where the laws of physics rendered stars impossible, or where time flowed in directions incomprehensible to their minds. For every universe that harbored intelligent life, there were infinite others that were empty and barren. This infinity posed a paradox. In a finite universe, questions like, "Are we alone?" could theoretically be answered with enough exploration and data. But in an infinite multiverse, such questions became meaningless. Any finite amount of information they could gather was dwarfed by the endless unknown. Were they a common occurrence or a rare anomaly? Did life like theirs make up 1% of all universes or 99%? The numbers lost all significance in the face of infinity. Their calculations always returned the same result: 0. Not because they lacked knowledge, but because no amount of knowledge could ever make a dent in the infinite. The multiverse rendered probabilities irrelevant. For every possibility they could imagine, there existed infinite universes where it was true, and infinite universes where it wasn't. This realization was not just an intellectual challenge, it was an existential one. It forced them to confront the limits of their understanding. Their entire civilization, the most advanced in the history of their cosmos, was reduced to a single, insignificant data point in an ocean of infinity. The multiverse was a mirror reflecting not their achievements, but their insignificance. And so, they were left with an impossible question. How do you measure yourself against the infinite? How do you find meaning in a sea where every discovery is drowned by countless unknowns? The multiverse was no longer a frontier to conquer. It was a reminder of their ultimate limitations, a vast, uncaring expanse that would forever lie beyond their grasp. The civilizational journey. In the beginning, the civilization's journey was like many others, a story of curiosity and survival. They were once beings confined to their homeworld, gazing at the stars with wonder. The celestial patterns above them inspired awe and questions. What were those points of light? Were they gods, guiding their fate, or were they destinations waiting to be reached? Slowly, over centuries, their curiosity evolved into something more structured, an organized effort to understand the world around them. They developed tools and methods, and from those humble beginnings, their path to greatness was set. At first, their discoveries were simple, yet transformative. They learned to harness fire, to farm, and to build shelters. These advancements allowed them to escape the precariousness of survival and turn their focus outward. They began to study the heavens, charting the movements of the stars, the cycles of the moon, and the rhythms of the seasons. Over generations, this knowledge became the foundation of their civilizations, influencing their myths, religions, and early sciences. As their understanding grew, so too did their ambitions. They invented devices to extend their senses, telescopes to peer into the cosmos, and microscopes to uncover the hidden details of their world. The scientific method emerged, giving them a way to systematically explore the unknown. Questions that had once seemed insurmountable were now within their reach, and the pace of discovery quickened. Over centuries, they unlocked the secrets of gravity, energy, and matter, piecing together the laws that govern the universe. The next great leap came when they turned their gaze from the sky to their own world, realizing they could harness its energy. They built machines powered by steam, then electricity, and eventually nuclear fusion. These advancements propelled them into the industrial age, where their mastery over energy and materials transformed their societies. They became a Kardashev Type 1 civilization, fully harnessing the power of their planet. But they did not stop there. With the resources of their world secured, they turned their attention outward to the vast expanse of space. They constructed rockets and launched probes, sending them to explore their neighboring planets. They established colonies on moons and distant worlds, transforming barren landscapes into habitable environments. Their solar system became a sprawling network of outposts, research stations, and industrial hubs. The move from a planetary civilization to a star-faring one marked a turning point in their history. They began to dream of the stars, not as distant lights, but as destinations. They developed technologies to harness the energy of their sun, constructing Dyson swarms, vast arrays of solar collectors that captured its immense power. With this energy, they built arc ships, colossal vessels capable of carrying entire populations across interstellar distances. These arc ships were not just tools of exploration, they were self-sustaining ecosystems, capable of surviving journeys lasting thousands or even millions of years. Inside, their passengers lived, worked, and thrived, carrying the hopes of their civilization to distant star systems. Some of these voyages succeeded, establishing new colonies in other parts of the galaxy. Others were lost to the void, their fates unknown. But the civilization pressed on, undeterred by the risks. As they expanded into the stars, their understanding of the universe deepened. They built particle colliders that spanned entire solar systems, smashing matter together at unimaginable energies to uncover the building blocks of reality. They constructed telescopes so powerful that they could peer billions of years into the past, observing the birth of galaxies and the first moments of the cosmos. They developed quantum computers capable of simulating entire star systems, predicting their behavior with stunning accuracy. Yet, as their knowledge grew, so too did their realization of the universe's complexity. The more they learned, the more they understood how little they truly knew. Mysteries like dark matter, dark energy, and the unification of quantum mechanics and gravity remained unsolved. These barriers loomed like unscalable mountains, challenging their belief that all questions could eventually be answered. Despite these obstacles, they continued to push the boundaries of what was possible. They reached the level of a Kardashev Type 2 civilization, harnessing the energy of entire stars. They transformed entire solar systems into interconnected hubs of activity, using their immense resources to fuel their insatiable quest for knowledge. Black holes became their power sources, their immense gravitational energy driving experiments that probed the very fabric of space-time. However, the limits of their understanding became increasingly apparent. They discovered that some questions might never be answerable, not because they lacked the tools or the will, but because the nature of reality itself imposed barriers. The universe, they realized, was not infinite in its accessibility. There were regions of space-time they could never reach, events they could never witness, and questions they could never fully resolve. The greatest challenge came when they began to theorize about the multiverse. This idea, born from their exploration of quantum mechanics and cosmology, suggested that their universe was just one of infinitely many. Each universe in this multiverse had its own unique set of physical laws, its own history, and its own possibilities. The implications of this discovery were staggering. If the multiverse were real, it rendered many of their questions meaningless. How could they measure their place in the cosmos when the cosmos itself was infinite? How could they calculate probabilities or understand their uniqueness when every possibility existed somewhere? This realization cast a shadow over their achievements. They had explored the stars, reshaped galaxies, and unlocked many of the universe's secrets, yet they found themselves dwarfed by the enormity of the multiverse. Their entire civilization, the most advanced in the history of their universe, was reduced to a single data point in an infinite sea. No matter how far they went, no matter how much they discovered, there would always be questions they could never answer. For all the barriers they faced, they refused to give up on their quest for understanding. They believed that the pursuit of knowledge, even in the face of infinity, was itself a form of meaning. Their story was not just about the answers they found, but about the relentless drive to explore, to question, and to grow. In this, they found purpose. Their journey was far from over, and as they stared into the infinite expanse of the multiverse, they carried with them the hope that somewhere, somehow, they might discover not only the secrets of the cosmos, but also the ultimate truth about themselves. Biological and technological limitations. For all their monumental achievements, the civilization was haunted by an undeniable truth. Their very essence was shaped by their biological origins. Their intelligence, creativity, and capacity for curiosity, while extraordinary, were limited by the finite structure of their minds and bodies. Their brains, evolved for survival on a single planet, were astonishingly complex but fundamentally constrained. They could process only so much information at a time, and their perceptions were narrow, limited to a small slice of reality defined by their senses. Memory was imperfect, prone to fading or distortion over time. Their physical bodies were fragile, requiring food, water, rest, and protection from the harshness of the universe. Even their lifespans, though extended by technological advancements, were mere moments on the cosmic timescale. How could beings with such constraints hope to grasp the infinite mysteries of the cosmos? To push beyond these limitations, they turned to technology. At first, they sought to augment their biology. Cybernetic enhancements improved their physical resilience, extended their lifespans, and expanded their cognitive capacities. Neural interfaces allowed them to connect directly to computational networks, accessing vast reservoirs of knowledge in real time. For many, the line between the organic and the synthetic began to blur. As their ambitions grew, they took the next step, escaping the confines of biology entirely. Entire generations transitioned into digital consciousness, uploading their minds into immense computational systems. In these virtual domains, thought was no longer bound by the constraints of neurons and synapses. They could process information at unimaginable speeds, simulate entire worlds, and explore concepts that their biological counterparts could scarcely comprehend. Yet even in this new form, they encountered barriers. Their original biological frameworks, the product of millions of years of evolution, continued to shape their perceptions and thought processes. No matter how advanced their systems became, they were still rooted in the biases and limitations of their creators. Artificial intelligences, designed to think beyond human constraints, often mirrored the priorities and blind spots of those who built them. Though faster, more efficient, and more powerful, these machines were not as free from limitation as they had hoped. Their technological triumphs brought them closer to the cosmos's most elusive mysteries, but also exposed new challenges. In their exploration of the quantum realm, they encountered the Heisenberg uncertainty principle, which limited their ability to precisely measure fundamental particles. They discovered that no matter how advanced their tools became, there were aspects of the universe that could not be fully known. The deeper they delved into the subatomic world, the more it seemed to resist their efforts to map it completely. On a cosmic scale, the limitations were equally daunting. The vastness of space and the finite speed of light meant that many regions of the universe were forever beyond their reach. Even as they colonized galaxies and harnessed the energy of entire star systems, they were bound by the unyielding laws of nature. They could see the universe's grand design, but only from a narrow vantage point defined by their own perspective. Despite these challenges, they refused to accept their limits as final. They developed artificial intelligences with radically different architectures, hoping to create systems that could think in ways fundamentally alien to their own. These intelligences were not meant to replace them, but to complement their understanding, providing insights into aspects of the universe their own minds could not grasp. Yet, even these new systems, for all their brilliance, seemed to reflect the boundaries of the civilization that created them. The civilization also experimented with genetic engineering, modifying their biology to enhance their cognitive and physical abilities. They created entirely new forms of life, tailored to survive in extreme environments, and think in ways no organic mind ever could. These creations, while extraordinary, were still extensions of the same fundamental desire, to overcome the barriers that separated them from the ultimate truths of existence. As they pressed onward, their quest became as much about understanding themselves as it was about understanding the universe. They sought not only to push the boundaries of their knowledge, but to redefine what it meant to be alive, to think, and to explore. Each breakthrough brought new possibilities, but also new questions about the nature of intelligence, consciousness, and the limits of knowledge itself. Their journey through the cosmos had shown them that no matter how powerful their technology became, they would always be bound by some form of limitation, whether biological, technological, or imposed by the universe itself. Yet it was this very struggle that defined their identity. They were a civilization driven by the relentless pursuit of understanding, determined to push past every barrier, no matter how insurmountable it seemed. And so they pressed on, their efforts fueled by the hope that somewhere beyond the horizon they might find the answers they sought, or perhaps something even greater. Interstellar and intergalactic expansion. Faced with the limitations of biology, technology, and the boundaries of the known universe, the civilization turned its attention to the stars. They understood that to overcome these constraints, they needed to expand their reach far beyond their home systems. Their gaze shifted from the confines of their galaxy to the endless expanse of interstellar and intergalactic space. This was not just a journey of survival, but a mission to unlock the secrets of existence itself. The civilization's interstellar efforts began with their arc ships, massive vessels designed to carry entire populations across the gulfs of space. These were no ordinary spacecraft. They were self-sustaining ecosystems capable of enduring journeys that spanned millennia. Inside, passengers lived in suspended animation, their biological needs reduced to the bare minimum, while advanced artificial intelligences piloted the ships through the cosmic void. These journeys were not without risks. Many ships vanished, swallowed by the darkness between the stars, their fate unknown. Yet for every ship lost, others succeeded, planting colonies in distant systems and extending the reach of their civilization. Over time, their methods of travel evolved. They built immense light sails, propelled by powerful beams of energy from home systems, allowing smaller, faster crafts to leap across vast distances. They developed wormhole technologies, creating shortcuts through space-time itself, though these remained experimental and fraught with dangers. For the most distant targets, they relied on generational ships, massive habitats where entire societies lived, worked, and died during the long journey to a new star. Their intergalactic expansion posed even greater challenges. While they had mastered the energy of entire stars, moving between galaxies required energy on an almost incomprehensible scale. To overcome this, they constructed Dyson swarms around dying stars, capturing every last watt of energy to fuel their intergalactic voyages. They also learned to harness the rotational energy of black holes, extracting power from the very fabric of space-time. With these advancements, they launched expeditions to neighboring galaxies, reaching the edges of the known universe. Communication between these far-flung colonies became an insurmountable obstacle. The vast distances introduced delays measured in centuries or millennia, making real-time coordination impossible. Each colony became its own autonomous entity, adapting to the unique challenges of its environment. Despite this, they remained united by a shared purpose: the pursuit of knowledge. Information from every corner of their civilization was collected, analyzed, and shared, creating a tapestry of understanding that spanned the stars. As they ventured deeper into the cosmos, they encountered not only physical challenges, but philosophical ones. What did it mean to expand endlessly into the void? Were they driven by a genuine desire to explore, or were they fleeing the realization of their own limitations? The infinite multiverse loomed over their efforts, reminding them no matter how far they traveled, they could only ever explore a finite portion of infinity. Their expansion also brought them closer to the mysteries they sought to solve. They observed the structures of the cosmos on an unprecedented scale, uncovering patterns in the distribution of galaxies and dark matter that hinted at deeper laws of nature. They built observatories that could detect the faint whispers of gravitational waves from the earliest moments of the universe, capturing echoes of creation itself. Each discovery brought them closer to understanding the nature of reality, but also revealed how much they still didn't know. As their civilization stretched across galaxies, they began to sense the looming shadow of the ultimate limits. They had conquered vast distances, harnessed incredible energies, and built a network that spanned the stars, but they were still bound by the fundamental laws of physics. The speed of light, the decay of information over time, and the relentless march of entropy placed boundaries on their reach. The expansion set the stage for a profound reckoning. They had reached the threshold of their capabilities, standing on the precipice of the unknown. Beyond lay the cosmic limits, the unobservable regions of the universe, the mysteries of black holes, and the boundaries imposed by quantum mechanics. These would define their next great challenge and lead them into the most difficult questions of all. What lies beyond what can be known? And how far could even the most advanced civilization go before it must confront the boundaries of the universe itself? Cosmic limits. As the civilization pushed the boundaries of its interstellar and intergalactic expansion, it became increasingly clear that the universe itself imposed fundamental limits. For all their ingenuity and technological prowess, there were barriers they could not cross, horizons they could not reach, and mysteries that resisted every effort to unravel. These cosmic limits, embedded in the fabric of reality, defined the ultimate challenges of their existence. One of the first and most immutable boundaries they encountered was the speed of light. This universal constant dictated not only the pace of their interstellar voyages, but also the limits of their communication and observation. No matter how advanced their propulsion systems became, the distances between galaxies meant that travel was measured in millennia, even for their fastest ships. The information sent from one end of their empire to another was hopelessly delayed, making real-time coordination across vast cosmic distances impossible. Light, traveling at its constant speed, could only traverse so far in the 13.8 billion years since the universe's birth. This created a cosmic horizon, the observable universe, that defined the furthest reaches of what they could ever see or measure. Beyond this horizon lay regions of space and time forever inaccessible to them, not because they lacked the technology, but because the universe itself had not yet allowed its light to reach them. Even within the observable universe, they faced another immutable limit, the expansion of the cosmos. The discovery of dark energy revealed that the universe was not just expanding, but accelerating in its growth. Over time, galaxies at the edge of the observable universe would recede faster than the speed of light, slipping beyond their view and taking with them any chance of interaction or observation. The universe, for all its vastness, was becoming increasingly isolated, fragmenting into unreachable islands of matter. Their efforts to probe the quantum realm brought them face to face with another barrier, the Heisenberg uncertainty principle. This fundamental feature of quantum mechanics made it impossible to simultaneously measure certain pairs of properties, like the position and momentum of a particle, with absolute precision. No matter how advanced their instruments became, they could never escape this inherent fuzziness at the smallest scales. The quantum realm remained a domain of probabilities and uncertainties, defying their desire for absolute knowledge. Black holes presented perhaps the most tantalizing and frustrating of cosmic limits. These objects, formed from the collapse of massive stars or the merger of galaxies, were perfect keepers of secrets. Their event horizons marked a one-way boundary. Once crossed, nothing, not even light, could escape. Everything that fell into a black hole became hidden from the universe outside, leaving only its mass, spin, and charge as observable properties. The information about what the black hole had consumed seemed to vanish, leading to one of the great paradoxes of modern physics, the black hole information paradox. For the civilization, black holes were both a source of fascination and despair. They built observatories to study these enigmatic objects, seeking clues about the nature of space-time and gravity. They even attempted to approach the event horizon, sending probes to gather data from the brink of the unknown. But the closer they came, the more they realized that the answers they sought were locked away, perhaps forever. The singularity at the heart of a black hole, where all known laws of physics broke down, represented a boundary they could neither cross nor fully understand. Another limit loomed even larger: entropy. The second law of thermodynamics dictated that the universe tended toward greater disorder, a relentless march toward a state of maximum entropy. Over unimaginable timescales, stars would burn out, galaxies would dissolve, and black holes would evaporate. The universe, once vibrant and full of structure, would fade into a cold, dark expanse, a state known as heat death. This ultimate fate imposed a temporal boundary on their existence, forcing them to confront the reality that even their most advanced technologies and civilizations were impermanent. Despite these barriers, the civilization did not surrender to despair. They saw each limit not as an end, but as a challenge to be understood and navigated. They probed the edges of the observable universe, seeking patterns in the distribution of galaxies that might hint at what lay beyond. They developed theories to explain the nature of dark energy and attempted to find ways to manipulate it, hoping to slow or reverse the universe's accelerating expansion. Their experiments in quantum mechanics grew increasingly ambitious. They explored the phenomenon of quantum entanglement, where particles separated by vast distances could remain mysteriously connected, sharing information instantaneously. While they could not break the speed of light barrier for physical travel or communication, they hoped to exploit entanglement to achieve faster-than-light transmission of information. Though the results were promising, the fundamental nature of quantum mechanics remained elusive. Faced with the mysteries of black holes, they turned to the idea of holography, a theory suggesting that all the information within a region of space could be encoded on its boundary. This concept, though abstract, offered a tantalizing possibility that the secrets hidden within black holes might be recoverable, encoded in the subtle patterns of their event horizons. The civilization built vast arrays of detectors, hoping to decode these patterns and peer into the heart of the black hole's mystery. Yet, as they pursued these frontiers, they began to sense that some questions might never have answers. The universe, for all its grandeur, seemed designed to withhold its deepest truths. Beyond the observable cosmos, beyond the event horizons of black holes, and beyond the uncertainties of quantum mechanics, lay a realm of permanent unknowability. It was not just a matter of insufficient technology or understanding. It was a reflection of the inherent structure of reality. The realization that the universe imposed fundamental limits did not deter them. Instead, it inspired a new phase of their journey. If they could not uncover all the secrets of the cosmos, they would strive to understand why those limits existed. This quest brought them to the brink of their next great mystery, the multiverse. If their universe was just one of many, perhaps the answers to their questions lay not within, but beyond, the ultimate challenge and the subject of their next pursuit. The multiverse conundrum. The civilization's relentless pursuit of knowledge brought them to a breathtaking yet disorienting revelation. Their universe, vast and intricate as it was, might be just one of infinitely many. The concept of the multiverse, born from theoretical physics and mathematical models, suggested that what they had long considered the entirety of existence was merely a bubble in a sea of countless others. Each of these universes could have its own set of physical laws, dimensions, and possibilities, forming an infinite landscape that defied comprehension. At first, the idea of the multiverse seemed like an expansion of their cosmic horizon, a new frontier promising endless discoveries. If their universe held wonders like galaxies, black holes, and intelligent life, what marvels might the multiverse contain? The possibilities seemed boundless, universes with dimensions beyond imagining, where time flowed in reverse or not at all. Universes where the constants of physics allowed for forms of life and matter utterly alien to their understanding. But as they began to grapple with the implications of infinity, the exhilaration gave way to profound challenges. The multiverse was not just infinite in scope, but infinite in every conceivable way. For every universe like theirs, there were infinite others where the laws of physics rendered stars impossible, or where life never emerged. For every intelligent civilization, there were infinite empty universes, vast voids of potential never realized. The sheer scale of the multiverse introduced a fundamental problem: measurement. In their universe, they could explore, observe, and calculate probabilities. But in an infinite multiverse, these concepts broke down. If there were an infinite number of universes with intelligent life, how could they measure the rarity or commonality of their own existence? Any finite data they gathered from their universe, or even from neighboring ones, was rendered insignificant in the face of infinity. Every percentage they calculated, every ratio they derived, collapsed into irrelevance. This issue, known as the measure problem, struck at the core of their quest for knowledge. They sought to understand their place in existence, but the multiverse offered no definitive answers. Were they unique, a rare phenomenon in an otherwise barren multiverse? Or were they just one of countless civilizations, scattered across infinite realities? The multiverse held every possibility, but it also obscured every certainty. Their attempts to explore the multiverse were fraught with difficulties. They had developed theoretical models suggesting ways to access other universes, using quantum tunneling or manipulating the boundaries of space-time. These efforts, however, were limited by the constraints of their own physics. The gateways they opened were unstable, and the glimpses they caught of other realities were fleeting and incomplete. Each experiment raised more questions than it answered, deepening the mystery of the multiverse rather than resolving it. Even if they could traverse the multiverse, they faced a paradox. No matter how many universes they explored, there would always be infinitely more beyond their reach. The multiverse, infinite in its nature, presented a boundary they could never cross. Every discovery they made, every insight they gained, was dwarfed by the infinite expanse of what remained unknown. Their greatest achievements seemed small against the backdrop of endless possibility. Philosophically, the multiverse forced them to confront profound questions about meaning and purpose. If every possible version of themselves existed somewhere in the multiverse, what did their actions mean? Were they merely one iteration among countless others, their struggles and triumphs mirrored and contradicted across infinite realities? Or was there something unique about their particular universe, something that set it apart in a way they could never fully understand? Despite these challenges, they pressed on, driven by the same curiosity that had propelled them to the stars. The multiverse, for all its enigmas, was a frontier unlike any other. They sought to decode its rules, to understand the mechanisms by which universes emerged and evolved. They hoped that within the multiverse's infinite variety, they might find patterns or structures that could offer some measure of comprehension. Their work on the multiverse brought them to the edge of a profound realization. If their universe was not unique, then perhaps the answers they sought were not to be found within it. The multiverse was not just a collection of universes. It was a challenge to their very understanding of existence. The boundaries they had encountered in their universe, spatial horizons, quantum limits, entropy, might themselves be mere reflections of deeper multiversal truths. As they stood on the precipice of this understanding, the civilization faced its greatest question yet. If the multiverse truly represented the infinite, was it even possible to know anything meaningful about it? And if knowledge of the multiverse was forever out of reach, what did that mean for their quest for understanding? These questions, profound and unsettling, prepared them for the next step in their journey. If their own biology and technology had once limited them, and now even the multiverse posed insurmountable challenges, they would need to go beyond their current forms of existence. The next phase of their evolution would not merely involve better tools or faster ships, but a transformation of consciousness itself, a leap into a state of being that might finally allow them to comprehend the incomprehensible. The final horizon, infinity. As the civilization evolved into forms of consciousness that transcended biology, even their most advanced minds were drawn toward a singular, daunting concept: infinity. Infinity was no longer just a mathematical abstraction or a philosophical curiosity. It had become the ultimate horizon of their understanding, a boundary that seemed to defy comprehension itself. To grasp it, they would have to confront the very nature of existence, knowledge, and meaning. Infinity pervaded every aspect of their exploration. In the multiverse, it presented an unending landscape of possibilities, where every potential reality existed somewhere. In the quantum world, it manifested as the endless complexity of particle interactions, the infinite dimensions of Hilbert space, and the ceaseless oscillations of quantum fields. On the cosmic scale, infinity revealed itself in the ever-expanding universe, where galaxies receded faster than light, and the observable cosmos became a shrinking island in an immeasurable sea. Their attempts to quantify infinity only deepened its mystery. They had long mastered the mathematics of infinities, from the work of their ancient predecessors to the insights of modern computational models. They understood that not all infinities were equal. Some were larger or more complex than others. Yet, when applied to the multiverse or the quantum realm, these distinctions often collapsed into paradoxes. How could they weigh their place in an infinite multiverse when every possibility existed in uncountable repetitions? How could they calculate probabilities when infinity rendered every calculation both trivial and insurmountable? As they explored further, they began to see infinity not as a barrier to knowledge, but as an intrinsic property of existence. It was not something to be conquered or fully understood, but something to be engaged with, an eternal question that defied resolution. This realization reshaped their quest, turning it inward. If the infinite could not be fully grasped, could it still be experienced? Could they find meaning in exploring an endless reality, even if they could never reach its edges? To approach these questions, they pushed their understanding of consciousness to new heights. They developed forms of awareness that could operate within the framework of infinity, perceiving not discrete entities, but the relationships and patterns that emerged across infinite scales. These minds could process not just individual truths, but entire systems of truths, seeing the infinite as a coherent whole rather than an overwhelming chaos. Yet, even these enhanced forms of consciousness found themselves humbled by the vastness of their inquiry. For every insight gained, infinity revealed new layers of complexity, new dimensions to explore. This pursuit led to a profound philosophical shift. They began to ask whether the act of understanding was itself the goal. Was their drive to explore the cosmos a reflection of something deeper, a fundamental aspect of consciousness that sought connection with the infinite? If so, their journey was not about reaching an end, but about engaging in an eternal process, a dance with the infinite that could never be completed, but would always hold value. As they contemplated these ideas, they turned their attention to the fabric of the multiverse itself. If each universe was a bubble in an infinite sea, what lay beyond the multiverse? Did infinity itself have a structure, a logic that transcended even the physical laws of individual universes? Could there be a meta-reality, a domain where infinities converged and the boundaries of existence dissolved into something more fundamental? To explore these questions, they embarked on their most ambitious experiment yet. They constructed a vast network of consciousness, spanning galaxies and dimensions, designed to merge their collective understanding into a unified perspective. This network, more than a tool, was an embodiment of their quest, a living representation of their desire to engage with the infinite. It allowed them to think not as individuals, or even as a civilization, but as an entity that could glimpse the multiverse from a perspective beyond time and space. Yet, as they prepared to activate this network, they knew they were approaching a final boundary. Beyond this point lay questions that might never be answered. What was the ultimate nature of reality? Was infinity itself an illusion, a construct of limited minds attempting to grasp the ungraspable? Or was it the ultimate truth, the source from which all existence flowed? These questions set the stage for their greatest challenge, confronting the infinite, not as a concept, but as a lived reality. The final horizon of their journey was not a destination, but a transformation, a leap into the unknown, where the boundaries of knowledge, existence, and meaning would dissolve into the infinite expanse. The stage was now set for the ultimate exploration, one that would transcend everything they had ever known. The limits of knowledge. The civilization had reached the threshold of the infinite, poised at the brink of understanding all that could be known, and yet humbled by the vastness of what lay beyond. Their journey had spanned eons, from their first cautious steps into the unknown to their transformation into entities capable of perceiving reality across infinite scales. They had conquered the barriers of biology, mastered the energy of galaxies, explored the depths of quantum mechanics, and ventured into the multiverse. Yet, despite all their achievements, they found themselves grappling with a profound realization. There are limits to knowledge, and these limits are not failures, but intrinsic features of existence. Their confrontation with infinity revealed that knowledge itself might be a process without an end. Each question answered opened new realms of inquiry. Each mystery unraveled revealed deeper layers of complexity. The multiverse, quantum mechanics, and the cosmic scale had taught them that some aspects of reality could never be fully grasped. Whether due to the fundamental laws of physics, the constraints of logic, or the sheer immensity of the infinite, there would always be horizons they could not cross. Yet these limits did not diminish their achievements. Instead, they gave their journey meaning. The civilization came to see the pursuit of knowledge not as a quest for ultimate answers, but as an expression of their existence, a celebration of curiosity, creativity, and the drive to explore. The very act of seeking, of striving to understand, was a form of connection to the universe, a way of participating in its unfolding story. As they stood on the precipice of infinity, they reflected on the journey that had brought them there. Their first questions, born from the simple act of looking at the stars, had grown into a civilization-wide endeavor that spanned galaxies and dimensions. They had built tools to extend their senses, created minds that transcended biology, and explored realms of reality that their ancestors could never have imagined. Each step had brought them closer to the universe, not as an object to be understood, but as a partner in a cosmic dialogue. The civilization realized that meaning was not something to be found at the end of their journey, hidden in the final answers to their questions. It was something they had created along the way. In their exploration, in their relentless curiosity, in their willingness to face the unknown, they had given their existence a purpose that transcended any single discovery. And so, they turned their gaze back toward the infinite, not with despair, but with hope. They knew that their journey was not over, that there would always be new horizons to explore, new mysteries to ponder, and new ways to connect with the universe. They embraced the idea that their role was not to conquer the infinite, but to participate in it, to weave their story into the fabric of existence, and to be part of the endless dance of understanding and being. The limits of knowledge were not walls to be broken, but horizons to be approached, always expanding, always inviting. And within those limits, the civilization found a profound truth. The search for meaning, for understanding, for connection, was itself the greatest journey of all. In the end, they realized that the infinite was not something to be solved or overcome. It was a mirror reflecting their own nature, a boundless source of inspiration that would guide them for eternity. And so, they continued, their journey stretching forward into the infinite, knowing that the questions would never end. And that was precisely why they mattered.